Hello guys, in this video lesson, I want us to talk about the geometric series which converge. The geometric series which converge. We're going to talk about the geometric series which converge. Now, not every geometric series will converge. So which geometric series converge? The geometric series that converge has got the ratio between -1 and 1. So we say, okay, if the ratio of the series, of a geometric series, is between -1 and 1, it means the series converge. So for geometric series to converge, its ratio has to be -1, has to be between. For the geometric series to converge, the ratio has to be between -1 and 1. So let us check at this geometric series here. 6, 3, 3 over 2, where the first term is 6, the second term is 3, the third term is 3 over 2. Does this series converge? Let's check. The first thing that we do, we calculate the ratio. We check if the ratio is between -1 and 1. So let's calculate the ratio. We know that the ratio is found by saying term 2 divided by term 1. And term 2 divided by term 1 should be the same as term 3 divided by term 2. If term 2 divided by term 1 is not the same as term 3 divided by term 2, the series won't even be geometric. So for the series to be geometric, term 2 divided by term 1 has to be the same as term 3 divided by term 2. And that's where we get our ratio. So what is term 2 divided by term 1? Term 2 divided by term 1, it's 3 over 6. So we see that, okay, term 2 divided by term 1, it's actually 1 over 2. And if you divide term 3 divided by term 2, you are also getting 1 over 2. So the ratio here is 1 over 2. So the question is, does the series converge? The answer is yes. Why do we say the ratio converge? I mean, the series converge. The series converge because the ratio of the series is between -1 and 1. It is clear, guys, in this case, that 1 over 2 is between -1 and 1. So this geometric series surely converge. Surely converge. So let me give you another example of a geometric series which converge. It will be 8, 4, 2. The series is continuing. This geometric series also converge. Let's check the ratio of the series. 4 divided by 8, it's 1 over 2, which is the same as 2 divided by 4, it's 1 over 2. So you look at the ratio is 1 over 2. It means that this geometric series is converging. Let me give you another example of a geometric series that converge. It's 9, 3, 1. This geometric series, it's converging. Why? Let us check. It's a matter of calculating the ratio. Term 2 divided by term 1. 3 divided by 9, it's 1 over 3. Term 3 divided by term 2 also, it's 1 over 3. So our ratio is 1 over 3. And we know that 1 over 3 is between -1 and 1. So this series also converge. Now, okay, we are talking about the geometric series which converge. Now, most of the time you will realize that when we give you a geometric series which converge, we don't give you the last term of that series. We just give you the first term, the second term, the third term, and we don't tell you where the series end. So this kind of a series, we call them infinite series. The series that do not have the ending point. They don't have the last term. So the series continues up to infinity. So one of the other questions that we can ask is for you to calculate the sum to infinity. We can also look for what we call the sum to infinity because our series does not have an ending point. Those series that does not have an ending point, we can ask you to find the sum to infinity. Now, okay, guys, we ask you to find the sum to infinity only in the geometric series which converge. Okay, how do we calculate this sum to infinity? The formula is a over 1 minus r. Okay, sum to infinity is a over 1 minus r. So let us calculate the sum to infinity of this geometric series here, 931 up to infinity. Let's find the sum to infinity of this series. So we say sum to infinity equals to, what is A? A is our first term. What is our first term on the series? The number which comes first, it's 9. So A is 9 over 1 minus. Now you have to find your ratio. We already calculate the ratio. It's 1 over 3. So you say 1 over 3. So you say 9 divided by 1 minus 1 over 3. Since you guys have a calculator, you just have to press your calculator here. So with me, I don't have a calculator. I will try to solve it. I see it's 9 divided by 3 times 1. It's 3 minus 1 is 2. So it's 9 divided by 2 over 3, which is the same as 9 times 3 over 2, which is 27 over 2. So the sum to infinity is 27 over 2. How much is 27 over 2? Is 13,5. Just use your calculator, guys. I'm hoping I'm right. 13,5, yes. 13 plus 30, yes, is 27 over 2. Half of 27 is 13,5. So the sum to infinity is 13,5. Guys, calculating the sum to infinity is simple. You just have to use the formula a over 1 minus r. A is the first term, r is the ratio. Then you press your calculator, you find the sum to infinity. So in this video lesson, I explained what is the converging geometric series, and I've also shown you how to calculate the sum to infinity of a converging geometric series. When we ask you to calculate the sum to infinity, it means that that geometric series is converging. So another question that I want to bring, which is our last question in this video lesson, it's a very interesting question. It's a typical question in your exam. We see it more often. Just give me some time to erase. Okay, let me write the sequence. It's 3, 2x minus 3 squared plus 3, 2x minus 3 cube plus 3, 2x minus 3 to the exponent 4. And we are saying the series is continuing up to infinity. I don't give you the last term. So my question to you guys is, for which values of x, for which values of x will the series converge? For which values of x will the series converge? We know that we are solving for x, but those values of x whereby the series is converging, we want those values of x whereby the series is converging. Now, most grade 12 students approach this question in this manner. They are saying, since the series is geometric, they are saying term 2 divided by term 1 is equals to term 3 divided by term 2. This is how they approach the problem. This is true, but it won't help you in solving this problem, whereby we are looking for the values of x where the series is converging. This won't help you. Term 2 divided by term 1 equals to term 3 divided by term 2 is a very valid statement in geometric series. But in this case, it won't help you, because this statement will give you the values of x whereby the series is geometric, not specifically the values of x where the series is converging. It will simply give you the values of x whereby the series is geometric. In this case, we are looking for the values of x where the series is a converging geometric series. Now, this is how you approach the problem. Step 1, you say -1. Actually, we are saying R should be between -1 and 1. You know that the geometric series only converge when the ratio is between -1 and 1. So this is your first step. You are saying, for me to find the values of x where the series converge, the ratio has to be between -1 and 1. Now, you have to find the ratio in terms of x. By simply looking at the series, I know that the ratio is 2x minus 3. This repeating guy in the bracket is going to be your ratio, but we can prove it. We can say, let's take term 2 and divide term 1. This is how we find the ratio. Term 2 divided by term 1. My term 2 is 3, 2x minus 3 to the exponent 3. My term 1 is 3, 2x minus 3 to the exponent 2. So how much is term 2 divided by term 1? Keep. And then we know that we are dividing powers of the same base. So you keep that base. The same base is 2x minus 3. What do you do to the exponent? When you divide powers of the same base, you keep the base, you subtract the exponent. So you're going to have 2x minus 3 to the exponent 1, which is 2x minus 3. So the ratio of this series is 2x minus 3. So you're going to say, okay, -1, 2x minus 3 is between -1 and 1. You calculated the ratio, guys. So you simply substitute your ratio with 2x minus 3, since you got the ratio being 2x minus 3. Now, remember, you are solving for x. You're going to take this -3 to the left side of the inequality and also to the right side of the inequality. So you're going to have -1 plus 3. When you bring it this side, you're going to add 3 this side. So it's going to be -1 plus 3, which is 2, And this side, you're going to have 1 plus 3, which is 4. So divide throughout by these 2. X is between 1 and 4. So those values of X whereby the series converge, they are between 1 and 4. Hopefully, guys, you will be able to solve this kind of problem. You can find the values of X whereby the geometric series converge. I'm tempted to bring another problem of this nature. Okay, let me raise quicker and try to find. Let's say I've got what can I put? I wanted to find another problem whereby the series determine the values of X whereby the series is converging. Okay, let me just write let me say we have got 2x minus 5 as my first term. My second term is 2x minus 5 squared. My third term is 2x minus 5. And the problem say find the values of x whereby the series is converging. We know that for the series to converge, the ratio must be between -1 and 1. So now you have to calculate your ratio. What is your ratio? By simply looking at this series, my ratio is 2x minus 5. So I'm going to say 2x minus 5. Yes, where there is a ratio, I put 2x minus 5. Now I have to solve for x. You're going to take -5 to the left side, and also you take it to this side. So when it comes this side, it's going to be plus 5. It was negative, it's plus 5. So I'm going to have -1 plus 5, which is 4. This side, I'm going to have 1 plus 5, which is 6. Divide everything by 2. So x is between 2 and, or 6 divided by 2 is 3. Yes. So the values of x are between 2 and 3. So those values of x, in those values of x, the series will converge. I tried my best to explain this. Okay, thank you so much for visiting my channel. I'll see you next time.